welcome back to Identity Insights by Indicio. I am your host, Tim Spring, and today I am joined by Indicio Deputy CTO Sam Curren to discuss the basics of DIDComm. This is the second in our three-part series on DIDComm, and in the first we sought to understand the general concepts and goals of the project, and in this discussion we'll be taking a deeper technical dive into how exactly the technology works. Thank you again for joining me today, Sam. I know I asked you a little bit about yourself in our last episode, but for those who haven't seen it, would you mind giving us a brief recap?
Sure. I'm an architect for Indicio, and I both work with the community as well as customers to help design solutions and to collaborate on stuff. I do a lot of community work. I'm involved in the Aries community, but I'm also a co-chair of the DIDComm spec working group at the DIF that created version 2 of the DIDComm spec that we're talking about. So heavily involved there. Also involved in the DIDComm users group that's also hosted at the DIF.
Awesome. Well, no, we appreciate you coming back again. So in the last segment, we discussed some cool uses for DIDComm, such as secure messaging between the holders of DIDs, but we didn't really get into exactly how that's accomplished. So I was curious if you'd be able to tell me a bit more technically how that works.
Yeah, so messaging between holders of DIDs. And so messages are created by the message sender, and they are created with all the information necessary for the message. They are packed, which what we mean by that is they're encoded and encrypted to the recipient, and then they're sent to the endpoint in the recipient's DID document. I'll talk about mediators in a minute, but mediators are used to relay the messages if the device is network challenged, like a cell phone or any other firewall device. And then that message can be unpacked, meaning it can be decrypted and decoded on the recipient side, and then the recipient has the message. And of course, the reverse can also happen for sending messages the other direction.
And sorry, you said a term that I'm not familiar with there. What is a DID document, and what does that do?
Oh, good question. So a DID is a decentralized identifier. And a DID document is what you get when you resolve a DID document. What resolution means is that you follow the instructions on how to obtain the DID document. Every DID method is different, but the DID document itself is information that contains keys and service endpoints related to the DID. So the public keys of that party, for example, are present in the DID document, and also a service endpoint for something like DIDComm can be present there.
So would you be able to tell me a little bit about maybe some different applications and maybe some examples that would kind of benefit from the technology?
I can. It could be any system, but the types of devices and applications that benefit most from the use of DIDComm are ones that interact with users and the devices they use. So that could be phones or laptops, or IoT devices, things like that. Particularly that tend to be seen as sort of the client and a client-server relationship. Those are the devices and the applications that benefit most.
Okay. And are there any technical differences to highlight between DIDComm and other methods of, obviously there's other ways to connect and communicate digitally?
Yeah, so it depends on exactly what you're comparing, but the thing that I'm going to compare DIDComm to is APIs, and APIs are really common, and the most dominant form of them may be HTTP-based APIs when you're using JSON or something else to communicate with an API. And those are good. We've done a lot of cool things with them on the internet. DIDComm itself is different in that it's a peer system designed on passing messages. So every party is in the peer, whether you're an organization or a device or a person, or one of the devices that people use, and you pass information in that way. Because it's message based, it has some powerful advantages. One of them is that it handles the greater array, as I was mentioning, of the devices that humans use, but it's also is oriented in a way that allows for semantic information to be passed. So that could be like chat, for example. Chat's a great peer-to-peer type of use case, but chat tends to be words just for humans to read on the other side, and not necessarily any semantic or sort of detailed information for the software on the other side to consume. And so DIDComm has the semantics built in so that you can pass information back and forth between software applications that relate to users but may not be messages that the user consumes directly. An example for that might be location sharing. I could text you my latitude and longitude, but that's not really useful for humans to look at without using some other software. And so if you can mark it as location, then the software on the other side could do something like render a map or calculate the distance away that that person is or something like that. And so that's why the semantic communication is powerful as part of DIDComm.
Makes sense. Often a lot of these devices, right, are kind of, and you touched on this a little bit, are kind of hidden behind firewalls that are offline, otherwise unreachable. Kind of what happens when DIDComm encounters that?
So this is really important because it's one of the differences between a message-based architecture and an API-driven architecture is that typically things behind firewalls can't host APIs, which puts them on sort of unequal footing, architecturally speaking. And so DIDComm uses the concept of a mediator to serve network challenged devices. Nearly all of the hardware that humans use are network challenged, either because of battery life or intermittent signal, whether it's a cell phone or a laptop that's on Wi-Fi sometimes and plugged into a network sometimes. And so mediators are really useful to allow those parties to receive those messages. But mediators are not trusted. They don't get to see message contents. The messages are always encrypted to the final recipient, of course, of that message. But by using one or more mediators, you can overcome firewall problems. And there's also a side effect of enabling increased privacy through herd privacy. When messages from lots of different users are mixed together, then it's a lot more difficult to analyze message patterns, for example, and compromise privacy in that way.
Okay, interesting. You mentioned something there that I'm a bit curious about, which is you mentioned one or more mediators. Is there ever a reason to use a bunch of mediators for something like this?
So technically speaking, you can overcome nearly any firewall related problem with just a single mediator. But you may want to use more mediators, either for flexibility on receiving messages or for that herd privacy aspect. Technically, you can use as many mediators as you would like, and the protocol supports that. It's uncommon to use very many. This is I joke a little bit and say that you can always choose the number of mediators that you want to use based on the thickness of your tinfoil hat. If you're looking for lots of herd privacy, more mediators will give that to you.
All right, good to know. I think you mentioned briefly in our last call, and this is kind of how I've been thinking of DIDComm, is it's a protocol, right? Would you be able to tell me what exactly and dive deeper into what DIDComm is
Uh,
exactly?
yeah, I totally will. It is a protocol, but it's something extra than that. It's a meta protocol, meaning DIDComm by itself does very little. There's very little in the spec. It doesn't define lots of protocols for interacting with all sorts of different things. Just the very basics to make the system function entirely. And then a meta protocol is designed to have protocols built on top of it. And so other protocols can be built to allow rich encryption with the batteries included features that DIDComm has, and I'll talk about what those are. Um, DIDComm includes authenticated encryption of messages, and this allows for the recipient, when they're decoding the message and decrypting it, to gain confidence of who the sender was. And so that's a useful feature. And so you don't really authenticate messages using a separate mechanism because it's built into the way that it works. And then DIDComm also contains the information on how to get the message to the ultimate recipient of the message, and that's set up by the message receiver. Specifies how they would like that message routing to occur through mediators that we were just talking about. And so the meta protocol defines all of the foundational elements that you need to use to make interesting things happen, but doesn't itself actually define what all of those interesting things are.
Okay, so who does define what those interesting things are then?
That's the right question. So anyone can build a protocol on top of a meta protocol, and so that's fantastic. No permission is needed to build a DIDComm protocol. You can go ahead and write one and coordinate with others in your industry or your vertical or your company or your friend group or anything that you want for implementation in the software that you're talking about. There's built-in ways in the meta protocol itself, the spec itself, to discover which protocols other parties support, so that you can figure out if they, for example, support the tic-tac-toe protocol, and you can play a game of tic-tac-toe with them, or whatever the use case might be. And so there's a little bit, just enough support to allow for discovery and interactions with the other parties that you that you communicate with using DIDComm as a meta protocol and all the protocols on top of it. And so there's a lot of different interesting things that you could do. So one obvious use case is verifiable credentials. That tends to be talked about a lot, particularly in the identity community. But other human-oriented protocols are very common as well. So human communication-oriented protocols, including chat, but also things like asking and answering questions or confirmations of actions. Even things like, I think I mentioned location sharing or sensor updates as it relates to a human can benefit from protocols built on top of that. And so the neat part about a meta protocol and having a bunch of protocols built on top is those protocols can actually mix in a really powerful way. So when you're communicating, for example, between two parties, you might use human chat-oriented messages, but also mixed with verifiable credential exchanges, both ways even, for verification or issuance, but also confirming things or sharing location, as I mentioned, or any of those other types of interactions that can be really useful to have in a trusted way. And so combining those protocols built on top of the meta protocol can be really useful.
Okay. So if you wouldn't mind, would you be able to tell me a little bit about how that interaction kind of looks, right? So if I have a protocol that I support, and I want to reach out to you and be like, hey, do you support this? Uh, what happens if you do? What happens if you don't? Obviously, if we do, then we create a connection or something, right? If you accept. But how does that checking? And if it doesn't, what happens then?
Yeah. So when we are talking about communicating with DIDComm, we tend to call it a DIDComm connection. And I don't mean to overblow what a connection means in this case. It doesn't mean that you have like a live streaming two-way thing all the time. What it means is that you are capable of sending a message to the other party and they're capable of sending a message to you. So one of the core protocols defined in the spec is a discover features protocol. And you can use that to ask the other party what features they support or share with the other party which features you support. And so one of those features, of course, is a protocol. And so to go back to my tic-tac-toe example, you can send a message that says, hey, do you support the tic-tac-toe protocol? And the other party is then capable of answering that. Those messages are not really human oriented, so I'm not going to get a message that says, hey, what protocols do you support? The software I'm using already knows what it supports. It'll just answer. It's also worth noting from a privacy perspective, there's no requirement that you disclose all of the protocols that you support to all of the parties that you have. I might only want to disclose the fact that I'm capable of engaging in a tic-tac-toe protocol with my other fellow tic-tac-toe gaming buddies, and may not want to reveal to the people that I interact with at church that I'm engaged in such salacious gaming, right? And so you can decide what you want to disclose to the other party based on any privacy reasons or expected interactions that you might have with them. From a user side, of course, they don't necessarily see all of that, but from a user side, they can see indications in their software about what protocols might be engaged in. So I might have sort of different symbols or different menu options or something indicating that this party is capable of interacting. So if I connect with one party, if I connect with my bank and they won't play tic-tac-toe with me, I don't get the play tic-tac-toe option in my software. But if I connect with you, Tim, and you can play tic-tac-toe with me because your software enables that, then that option could be visible to both of us. And so it can be used to customize the user experience based on the capabilities of the other party that you're connected with.
All right, very cool. So you mentioned verifiable credentials briefly. Could you talk a bit more about how they relate to DIDComm?
Yeah, so verifiable credentials are a really common topic. I mentioned, especially in the identity community. Verifiable credentials are a really excellent mechanism for making data or trusted data portable. Data could just be information, but if I just provide you something, you don't necessarily know if I just made it up or if it's real. And a verifiable credential allows me to present information to you that has been certified by another party. For example, if you needed my mailing address, I could just tell it to you. But if you really needed to make sure that it was both my mailing address and a valid real address, then maybe I could give you a credential that has been issued by the Postal Service or some other authority that has done the appropriate verification. And because the credential contains that with alongside cryptography and signatures, et cetera, you can verify that information without having to necessarily go ask the originator of the message. You don't have to go to the post office and say, hey, can you check this address for me? Which is both more private and privacy preserving, but also faster and cheaper. Verifiable credentials are really useful in DIDComm relationships by adding trust to the DIDComm relationship. Just having a DIDComm relationship itself doesn't necessarily prove to you anything about the other party. And so the exchange of verifiable credentials can elevate the trust that you have in that relationship to whatever level necessary for the types of interaction you're going to have. If you are someone that I met at a conference, I may not necessarily have a high level of trust. If you are my bank, I probably want a really high level of trust. And in fact, you are my bank, and that you are as a bank, FDIC insured, or what other accreditations are useful in those particular circumstances. And so that establishing of trust on a DIDComm connection is a really powerful way to leverage both technologies and kind of the intersection of how they apply to DIDComm. You can use DIDComm to issue and to verify verifiable credentials, but the trust that you benefit from also affects all of the other protocols that you engage in. And so this is a little bit of a silly contrived example, but in the beginning of a tic-tac-toe game, we might want to exchange a credential of our tic-tac-toe league rankings. And that way I know that I'm playing another high-level player or something as part of that process. And that can be useful alongside or leading up to a game that we play, using some different protocol. And so the interplay between protocols and the trust gained from verifiable credentials is really important there.
Well, it sounds, as a more non-technical person, it sounds pretty cool, but pretty complicated as well. So I was curious how difficult it is to kind of get started using DIDComm and what kind of technical background you would recommend for someone that's interested in learning more or just try to work with the technology.
Absolutely. If you enjoy reading specs, the specs are there, of course, for your reading enjoyment. But there's also a bunch of existing libraries that have been created to help you get started with that sort of a thing. It is important because of the architectural differences between, say, like APIs and DIDComm, that some of the basics that you understand. And so seeking some additional resources online to help you understand those concepts is important. Sometimes there's trainings available that you can find as well. DIDComm.org is a reasonable place for that. That's being updated and will continue to be so with new information about DIDComm itself, of course. But that will help you gain some of the starting concepts that you need to understand, how to put it in place. And that's a useful resource to get going.
Okay. And for those developers that are, maybe on the fence, like, hey, it sounds cool, it sounds complicated, what advice would you give those people that are kind of like, I don't know if I should try it or not?
Take a look at the technology so you understand it. And then I think it's important to understand the benefits that it provides that are not necessarily easily obtained by other technologies or other architectural methods. So DIDComm is, I have to again reference a blog post written by Daniel Hardman, a friend of mine, called Big Desks and Little People. That's easy to Google up, and that's an excellent blog post. We can include the links as well in the show notes here, but the it highlights a problem about the architecture of the internet and the fact that APIs don't place the participants on the internet on an equal footing, and DIDComm is designed architecturally speaking to fix that. Such that we can be peers in their interaction, and it still means that we still have the roles that we play. My bank is still my bank, and I'm still a person that might have an account at the bank. But from an architectural perspective, we are on equal footing, and that's really important for the development of technology and the representation of not just the types of interaction that we have, but the types of trust that are possible on the internet. It's far more common for institutions to want to verify people, for example, than for people to be capable of verifying institutions, and that's something that needs to be fixed at an architectural level to really gain the trust that we want. So consider the fact that the DIDComm is one of these technologies that can enable a fundamental change in the internet to get us the types of interactions, the types of trust, and the other features that we want on the internet in the future.
Sounds good. No, that's really funny. I don't think it's gonna stay in, but I actually just recently got an email saying, "Hey, you have this bill for some healthcare stuff," and it was from a place I'd never heard of before. So like having
I,
that kind of
I
thing
just
would
had
be
I just had a friend who's relatively techno savvy get tricked into this thing that luckily it didn't, the scam didn't go all the way through, but she was notified that she'd like failed to appear in court, and so there was a way to resolve it, but she had to make a fee penalty payment to the right person, and she was freaked out about this whole thing, and ended up being able to resolve. She resolved the issue by showing up at a police station and asking them how to resolve the issue, and they're like, "That's not a thing."
Yeah, wow.
And she is not she's a very, very smart person, but was just sort of caught in a moment. It was executed really well, and her lack of ability to verify the trust in the interaction that she had, around like coordinating a court appearance or something else, is a huge issue. And so a lot of people say, well, like, I don't really need to trust the interactions I have online. And I'm like, well, do you? You may not be thinking about this very deeply, because it touches us all in really important ways, and it's become a regular activity for us to wade through scams, and they propagate through email, text message, social media. They're everything that we invent will have things for that. And so DIDComm is no different, which is why we need the trust layer that verifiable credentials can provide, because otherwise we're never going to escape this particular problem. We have to have reasonable ways of establishing trust, so that we can understand the implications of the messaging and how to interact with those that we message with.
Absolutely. Well, it looks like that is about our time for today. If you at home are interested in learning more about verifiable credential technology and would like to learn more, please be sure to subscribe to the channel. We'll continue to bring you some more educational content. If you have any questions or specific topics that you'd like for us to address, please go ahead and leave a comment below, and we'll be sure to read and address them. And thank you again to you, Sam. We'll make sure to include the links, as well as that link to Daniel Hardman's piece, in the description below. So go ahead and click those to learn some more. And are there any just final thoughts or key takeaways for the technical aspects of DIDComm that you'd like to share?
If you're interested, come and join us. There's the DIDComm users group, is a technical users group, and that meets weekly at the Decentralized Identity Foundation. We've got a Discord channel, also be in the notes down below. Come join us, ask questions. We would love to help you learn more, and we're always actively seeking to improve the online resources. And so check back on the regular, or ask for specific things that you would like clarification on, and that will guide our efforts. Thanks for listening.